Whenever you go through any lesson, particularly physics or chemistry or mathematics, here we are dealing with the first lesson, that is the solutions in CBSE class 12. So you've got the list of topics to be covered here. You have to make the topic brief first of all. So you can make use of this flashcard and just to try to list out what are the major topics, that is subtopics to be discussed. So here you've got types of solution, then expressing concentration and concentration of the solution, then solubility, and then under the solubility you've got the subtopic, and then you have vapor pressure, then that is the fourth one, and the fifth one is ideal solution, that is ideal and non-ideal solution. Sixth one, colligative properties. So from this it's clear that colligative property, that is the sixth one. And under six you have got the variety of subtopics. And finally they end up with the abnormal mass. Okay. After that, that is you are supposed to go through the exercise and finish the problems also and make a note of summaries also. So you have got almost seven subjects. So when you are asked to find out or to tell the important subtopics, you should be able to tell the main subtopics. What are the major subtopics? So if you have written this, probably it helps you like a checklist. Are you will follow? So that is the topic. Now you are asking some doubt in that is Henry's life. Is it? So that comes under what, that is, what is the topic? Solubility. So it comes under the topic solubility, right? And here in solubility we have what are the subtopics here? Solubility. Point number one, solubility of a solid in liquid, solubility of a gas in liquid, and then that is yes. So now within the solubility of gas, so it is something concerned with the gas and liquid. That is the key point you have to know. Okay, so you can make a lot of key point meaning, that is liquid gas in liquid system. This is the key point. Many gases dissolve in water, or the same. You read line by line. Solubility of gases in liquids is greatly affected by. So now they are talking about what are the various factors that influence the solubility of gas. If you want a gas to be dissolved very easily, or if it is dissolving in a with a great difficulty, what are the factors influencing? So the first factor is that is influenced by pressure and temperature. Are you able to follow? So these are the two important points. So solubility here depends on, you can make use of these, symbols very effectively. Okay, so that your entire notes will be in that tension, and use always this flashcard. So S is proportional to what? That is pressure and temperature. Okay. Then the solubility of gas increase with the increase in pressure. It means it is directly proportional to pressure. For a solution of gases in a solvent, consider a system. Now they are going to explain about the pressure, how the pressure is influenced. And this comes under what? This pressure influence. So here you can note down the Henry's law. Therefore, this law is connecting the solubility and the pressure. In what way it is connecting? Now it is very easy. Immediately you have to identify the related equation. Now we will follow. So whenever you tell the name, for example, this is Henry's law. Okay, so this is the name of the law, Henry's law. So immediately you should be able to tell the equation. What is that? P is equal to K H, and then yeah, this is called chi actually. In your book it is written X, but you can call it chi. Chi is nothing but mole fraction. What is this mole fraction? Mole fraction is, for example, if it is a solute, then It can be what? N2 by N1 plus N2. That is the total solution. Okay. And what about K1? K1 is N1 divided by N1 plus N2. What do you by 1 and 2? 1 represents solvent, 2 represents solute because one that is solvent occupies the major portion. So we call it K1. Okay. Right. Now, in this case, the partial pressure of the gas in vapor phase. So, the partial pressure of the gas in vapor phase. Okay, the partial pressure of the gas in vapor phase. I'm writing, don't worry. So, vapor phase. Therefore, P is equal to this is the partial pressure of the vapor. So, what is P? Partial pressure. What do you mean by partial pressure? Then that is the next concept. Okay, for example, let me consider two chambers, and here I have got one gas, and here another gas. So the pressure exerted by gas 1, the pressure exerted by gas 2, they are respectively represented as P1 and P2. Now this is a mobile partition. I am removing this partition. What will happen? These two gases will be mixed so that it results here total pressure. Okay. So the individual pressure that is summed up to get the total pressure, right? So P1 plus P2. This is called partial pressure. But P1 and P2 are the partial pressure. Yes. So it means what is the constituent? That is very important. So in that case, partial pressure means the pressure exerted by the component, one particular component. Okay. So partial pressure of the gas in vapor phase is proportional to the mole fraction of the gas. Here, as I already mentioned, this is a gas liquid system. See, whenever we call the solution, we are mistaken that this is only a solid liquid solution, like the sodium chloride dissolved in water. That not that is not only the solution. We have got liquid solution also. We have got gas liquid solution also. In all these cases, the liquids are solvent and solute, liquid, gas or solutes. So in this, for example, milk that is diluted in water. So liquid system. And what about gas? For example, soda, okay, aerated liquid, right? So when you drink any that is a fizzy drinks like any beverages, it contains some what? Yeah. So the air is present here, the gas is present, the carbon dioxide, that is carbonated liquid, we call it. So this air, this gas, in to what extent it is dissolved in liquid. So that is described. For example, in the case of solute, it is expressed as what some concentration tau, right? And that concentration is expressed as what we, especially in colligative properties, we take molality, right? Molality in terms of the weight of the solute, okay? Whereas in the case of gas, now here he has taken that is mole fraction of that gas, particular gas. In fact, this gas is the solute here. You can put two, and this is the solvent one. So in that case, there is chi2. You know very well. What is chi2? N2 by N1 plus N2. Because that is the solute here. So there's got certain pressure here. And that pressure is proportional to what? This pressure is proportional to, vapor pressure is proportional to chi of gas. For example, if we want to put the P2 means this is chi2. Okay. And here, when you remove the proportionality, you have to introduce a constant. And that is called Henry's constant. Do you understand this? That is why. So now you can easily state the Henry's law because you are thorough with the formula. What is Henry's law? You can tell this as a formula. P is equal to KH into A. That's all. Now, the partial pressure of the gas in vapor phase, okay, is proportional to, that is partial pressure of the gas, that is the solute, is it not? Is proportional to the mole fraction of the solute and that particular gas. That's all. So if you want to put G, that is gas, you can put nothing wrong in that. So Pg, what is that? That is the partial pressure of the gas in the solution. Is proportional to mole fraction of the solute, that is the gas, right? So it is proportional to the mole fraction of the gas. That's all. That is the law. So only thing is you have to remember the formula. Audible for you? Clear? So till here, that is, they are talking about the pressures only. And you may get a confusion. Sir, there are two definitions here. Henry was the first to give the quantitative relation between pressure and solubility. Yes, we are talking about pressure and solubility. These two factors are related. Okay. When the law states that at constant temperature, so here the temperature is kept constant, the solubility of the gas, so we once again take the solubility, is proportional, directly proportional to partial pressure. He said it is proportional to partial pressure. Okay, other gas present above the surface of the liquid or solution. But Dalton, a contemporary of Henry, also concluded independently, he did separately, that the solubility of the gas is a function of partial pressure. So both of them found out, they discovered only the same concept but at different locations. They are contemporaries. So, and in his wording, that is Henry, he suggested the partial pressure is proportional to mole fractions. He has further explained about the solubility. So this solubility is expressed as mole fraction in the case of Henry. Horrible follow. But in the case of Dalton, what he suggested is the lost result, etc. Here also he defines it is based on the what? Solubility is directly proportional to partial. Solubility is based on the partial test. Either way it is same. So you can make it as this one as the more defined one. So when you are asked what Henry's law is, you can easily say P is proportional to chi. So what is P? Vapor pressure. Vapor pressure of what? Vapor pressure of gas. So you try to ask so many questions, you try to develop so many questions out of your own interest. Okay. And thereby, before anybody asking you, you will be able to approach in different dimensions and be able to answer your question. Anybody else? Let anybody else. Okay. You just ask yourself, okay, in which case it is applicable? Gas liquid system, right? And what is the solubility term? Mole fraction. And what does this P represent? Partial pressure of what? Gas. And what is that gas? Whether it is solvent or liquid, or I mean solute or solute or solvent? This is solute. Solute in the form of gas, because we already explained it is under gas liquid system. Is it clear? Yes, sir. Okay. Now you can see here they are given some activity here. What is that? That is, they are given two diagrams. The effect of pressure, okay, on the solubility of gas. The concentration of dissolved gas is a proportional to the pressure on the gas above the solution. For example, when you put W1, okay, this is a piston. It is a weightless piston, frictionless piston. And here you have got the gaseous molecule and along with the solution. Okay, so when you pressurize it, what will happen? By putting more amount of weights, you are increasing the pressure. So when you increase more amount of I mean the solutions are dissolved here. The gas particles are dissolved because of the pressure. Are you able to follow? Because these pressures, they that is increase in the solubility. So they are directly measured, I mean established with this simple experiment. Okay, right? Okay. And you can find the Henry's constant here. For instance, value of Henry's law constant for some of the selected gas in water. So why they have given such a table? It is not for memorizing, but for comprehending certain facts based on the figure. We can figure out some of the important parameters or aspects or the facts here. You just look at it, these are all the temperature, K, right? Because we are talking about the influence of the temperature also. And here, helium, neon, helium, hydrogen, nitrogen, nitrogen, oxygen, oxygen. We just go through all these gases at a different temperature, and what is that? Henry's constant here 144.97. And here for hydrogen, it is drastically come down, right? And in the case of nitrogen, 76. In the case of, again, nitrogen and oxygen here at 303, you just compare these two. At 293, it is 76.48. At 303, it further increases, right? So now you can find out what the influence of temperature also here. So it means from this it is clear that solubility of gas increases with the increase of temperature. So this is another important fact because we introduced this concept based on two important parameters. One is solubility of gas is based on what? That is pressure and temperature. So Henry's law, he clearly explains about the influence of the pressure and um, and also the solubility. But here you can find the temperature is also influencing from this table. Are you able to understand this? So these tables should be scan that perfectly and try to get some of the results and try to ask yourself some questions. I mean, if you are not in a position to ask questions, you please go through various books. What is various books? Reference books, best reference books. I already suggested in your topic call. Okay, so please go through that, and I have given various problems also based on this. Okay, kindly go through that. Now, this is a problem associated with the and based on the Henry's law. What is that? Nitrogen gas is bubbled through water. Okay. So nitrogen gas is bubbled through water. Okay. So try to write down the given parameters first. Nitrogen. It is passed. So this is the nitrogen in water. Is it not? Nitrogen in water system. Nitrogen is a gas. Water is a solid. And the temperature given here is 293 Kelvin. Okay. How many millimoles of nitrogen gas would dissolve? So millimoles. Yeah. Okay. Milli means 10 power minus 3. Mole, okay, of gas in 1 liter of water. So this concentration is asked. The concentration of this gas is asked. Okay. And the volume given is 1 liter. Right? Okay. Now here uh, given Henry and assume that nitrogen exerts a partial pressure. They are given the partial pressure 0.987 bar. Bar is one of the units of pressure. You've got various pressures for, various units for pressure. One is atmosphere, bar, then torr, and then Newton per meter square, Pascal, kilopascal. So we have got variety, okay. And we have got pounds per square inch also, PSI, right? So P is equal to 0.987, right? Now, this much bar. Here, Henry's law is a constant that is given, KH, is it not? So KH is equal to what? At 293, 76.48 kilobar. Okay. Now our idea is to find out the concentration. Are you able to follow? So we know very well the Henry's law. What is Henry's law? That is, let us go to the solution. Henry's law KH into K2. Is it not? That is the nitrogen is equal to particle pressure. This is the basic law. Now what are given here? P is given. And then KH is given. You can find out K2, no? Mole fraction. So K2 is equal to what? That is P divided by Henry's constant. Okay. So what is the pressure? 0.987 bar divided by, and what about this KH? It is given as a kilobar. So into 10 power 3. Is it not? That is 76.48 into 10 power 3 kilobar. Okay. Right? So when you divide this, let us divide 0.987 divided by 76.48. What is the value? 0.0129. Okay. So this is 0.0129, right? Into 10 power, this 10 power 3, when it goes to the numerator, it becomes minus 3. Now you can convert this into a scientific notation. Therefore, 1.29 into, we have pushed the two digits, so into 10 power minus 2, get minus 3, so minus 5, right? Okay. Now, what is the unit for this? It has got no unit. You have to say that is simply mole only. Okay. So, because this is mere count, okay, because you have got kilobar, this is bar, so bar cancelled, right? Yes. Now, listen, here they have asked the concentration, not the mole fraction. So we need the concentration. How to get the concentration from this? Concentration means in terms of number of moles. Okay, so we know already chi2 is equal to n2 divided by n1 plus n2. But that is, we have to find out the n2, right? And we have got already chi2 here. Are you able to follow? We have got already chi2. And we have to find out that is n1. Okay. Here chi2 is already found out. How much? 1.29. Now we have to find out the n1. How to find out the n1? So the n1 is, for example, what is the n1? Number of moles of water here, right? What do you mean by number of moles of water? That is weight of water divided by molar mass of water. Are you able to follow? Right? So it means weight of water here, that is 1 liter. We are taken, they have given 1 liter. That is the liquid solution. That is water here. So in that case, 1 liter is equal to 1000 ml, right? So 1000 ml is equal to, what is that? 1000 milligram. That is 1 kg. Is it not? Are you able to follow? Right? So 1000, you can take this as 1000 gram, not milligram, 1000 gram. Okay, so divided by, because 1 liter is equal to 1 kg. 1 kg is equal to 1000 gram. Okay, so 1000 gram, right? Divided by, what is the molar mass of this one? 80. Now, in your book, they will not have given this. 1 liter contains a 55.5 moles. Simply they will say, but you should know how to get that also. Now you take this 1000 divided by 18, that is the molecular weight of water, is it not? Because 16 plus 2. Now take this 1000 divided by 118. So 18. What is that? So 55.55. I hope now you should be able to understand why you are getting 55.55. And this is the mole. Mole of what? Mole of water. Now we know N1. What is N1? Okay. And from this we can easily calculate. Okay. Right. So chi2 again is equal to n mole, because we do not know, we'll put n2 divided by, and n1 plus n2. Okay. Actually, in summation, this is a very minute molecule. Okay. And I mean, that is the molecular respect number of moles is very, very less because it's a dilute solution. So on addition, n2 can be neglected. Do you understand? So instead of putting n1 plus n2, you can simply put n1. Why I neglected N2 in denominator? Because N2 is much less than N1 for dilute solutions. These are all dilute solutions only. You have to apply that thought also here. Okay. And since it is removed, it can be ignored. But you may ask me, sir, you are ignoring N2 in the addition, but you are not ignoring N2 in the numerator. Why? Because in multiplication division, smallest number will have greatest impact. Do you know how? Let me explain that one also. For example, when I say 1 plus, I have got some 1 plus 0.001. Let me say this is n1. This is n2, right? So 1 plus 0.001, roughly it is 1 only because it's very small, 1.001, right? But 1 into 0.001, what has happened here? It will degrade the value. Okay, this becomes what? 0.00. Okay, so can you say roughly 1? No, because it will have its own multiplication impact. And that is why you cannot ignore smallest number in multiplication and also division. In multiplication, it will further drag the value. It will bring down the value. Is that not? Okay. And that is why you have to be very careful about your choice of friends. If you choose a bad guy, definitely he will see to that you will be dragged. Okay. Right. Take care. Always be careful about your friends. Now, here, let me say 1 divided by 0.00. You just see the impact. 1 divided by 1.01 means what? 1 power minus 3, is it not? It becomes 1000, yeah? 10 cube means 1000. 1 becomes 1000. I hope now you should be able to understand the impact of these negligible figures in addition, subtraction, multiplication, and division. So in multiplication and division, you cannot ignore it, even though it is small. Okay, right. But in case of addition and subtraction, you can. And that is why I have taken n plus 1, n1 plus n2 is roughly equal to n1 because n2 can be neglected. So I have taken this one. Okay. So now I can substitute here. So phi 2, what is the phi 2 value here? Tell me. 1.29 into 10 to the 1.29 into 10 power minus 5, right? That is equal to what is N2? N2. You have to find it because that is asked. N2 number of moles in liter, right? Divided by why I have taken I mean 1000 gram of water because 1 kg. That is since the specificity of water is 1, weight and volume will be same. Okay, that is logic you have to take. Now N2 divided by, and what is the N1 here? 55.555. Then what you can do? N2 is equal to, now you can multiply. So 1.29 into 10 power minus 5 into 55.55. So you do. So we have got already this 55.55 into 1.29. So that is 71.67. So 71.67 into 10 power minus 5. This much more. This is N2. And what is asked in the question, you just look at it, assume that, etc. What is the, how many millimoles they have asked? Millimoles means what? 10 power minus 3. And what we have got? 10 power minus 5. So you have to interpret in terms of millimoles. So you have to divide by 10 power minus 3. Okay. Okay. So what you're supposed to do? N2 is equal to, now I want to call it as millimole. So milli means a 10 power minus 3. So that should be, yeah, divided by 10. Okay, divided by 10 power minus 3 means 10 power plus 3, right? Yes, sir. Okay, so into 10 power plus 3. And what about this? 71.67 into 10 power minus 5. Okay, 10 power minus 5. So in that case, it becomes what? 10 power minus 2. So 71.67 into 10 power minus 2 millimole you can take in. Now N2 is equal to what? 0. Because 10 power minus 2. 7167 what millimole. This is the way you have to solve the problem. Okay. Now you are finished. Okay. Immediately don't, jump to the next cause. That is very, very bad, right? What you are supposed to do? Now, you please check whether any other problems are given based on Henry's law. You have got here. Why don't you attempt this? Do you understand? Yes. You have got this. So you have to attempt this as 1.6 and 1.7 because that is based on Henry's law. And you please check whether any other, probably that is for each concept. And after that concept, they discuss only the problem related to the previous concept only. Okay. So definitely now you can go to your exercise. Kindly go to your exercise. But you had the bad habit of attempting the exercise separately, studying the text separately. Am I right? And that is why you are getting bored. When you look at this huge number of, oh, how many problems, how can I solve all these 41 problems? When you, in this case, you have to apply the British concept, divide and rule. Split the problems into pieces so that it will be pieces and that can be easily handled, right? Now you just identify what are all the questions based on Henry's law. State Henry's law. So this is one question, correct? Partial pressure of ethane, etc., is the bar. So this is also solution contains ethane. What will be the partial pressure? So another problem. And delta H makes is this is Raoult's law. And so likewise, you kindly go through the problems. Okay. Identify which are all the problems based on Henry's law. Correct. And from which we can easily, you just look for, see, for Henry's law, what are the parameters associated? If it involves any Henry's constant, right, or mole fraction, or partial pressure, so these are the three parameters. If these three parameters are found, definitely you can identify that problem is based on Henry's law. For example, you have got 1.35. So likewise, identify these problems and try to write down. Your problems should be written. You must make the problem friendly to you. So that, see, by tracking this, now how I am getting familiarized with such type of problems here. What am I doing? I have finished the Henry's law concept. Immediately, I was discussing about the example. Then we were discussing about the next problem. Okay, and immediately you come here, you will have only 4 or 5 problems associated with the Henry's law. You identify that, try to write down. Once you write down means you become familiar with that problem, but you don't have the practice of writing down the problem. Kindly write. Once you write, for example, Henry's law, constant to molarity, methane, etc., means you become friendly because how you can remember things, you cannot forget the experience, right? When I say something, you will definitely forget. But when I make you to think and involve and the experience cannot be forgotten so easily. So solving the problem and moving with that and thinking about that, writing about that, don't that is underestimate your fountain pen or any other pen. When you write, that is it is called muscle memory. It is something pena is your pen is something like your antenna that receives the signal from the book to brain. Try to understand. Okay. Right. May God bless you on this Guru Purnima day. And I hope I have now thoroughly discussed about the Henry's law. And what is your duty? Uh, Practicing sums. So you want me to do that one also? Then what is your part left? Okay? Right. Thank you.